Calculus. Test. Ethan, you create a lot of apps. All right, so we have started talking about limits, and the first idea about limits is just so let's review a little bit yesterday. Yesterday, we talked about how to find limits using graphing. Okay, let's kind of go through yesterday. Jing, this video is recorded from yesterday, so you have to go back and watch it. I can send you a link if you need it. Before you leave this classroom, I need to add you to BC group chat rather than AB group chat. Okay, so we start with this question: limit x approach 0, x over square root x plus 1 minus 1, and we know that is equal to 2 looking at it graphically. And we talk about limit does not exist on 3 situations. Okay, on 3 situations. So Jing, you probably have to write down notes here, unless you can register stuff very quickly. So limit does not exist at 3 situations. Limits from x approach to a from the left does not equal to right. Unbounded behavior oscillation. I can probably just ask you when limit does not exist, or maybe some type of application. We also talk about absolute value x over x graph. Eventually become like this. The reason why is definition absolute value. You can break up 2 functions. We also talk about oscillations. Oscillation, where on the center of the graph is going to be like oscillating between 1 and -1. We talk about evaluate limits using graphically, and we go through all those questions. So Jing, gotta go watch a video. Last part is we talk about start with simple limits and finding limits algebraically, and we're going to talk about trig limits today. So trig limits is going to be hard for you because last year that's one of the hardest thing. This year we're going to do that as well, but we're going to start with algebra first. So how do we find limits algebraically? We can use limits. First, plug in the value. If you get a value, you are pretty much done. If you get a value here, that you are done, right? If you get a 0 over 0, it's called indeterminate. And we already know indeterminate, there's a few different ways to resolve the issue, which is factoring, cancel, combine fraction, conjugate, and absolute value. We're going to talk about this maybe a couple more days. No, test is not tomorrow. I know as much Ethan want to test tomorrow. No, I'm not going to do that to you guys. All right, so so I want you to do math here if you ever have a 0 over 0, because that's not known as undefined, it's known as indeterminate. If you factor and cancel, then you're gonna start to see the trend. The trend is to figure out how to cancel the denominator. Now, if I were to cancel this, I'm going to say limits x approach to -3. If I plug in -3, I'm going to get 0 over 0, which is indeterminate. So we can factor this. It'll be x. What is the factor? X minus 3. X plus 2. Wait, did I write down a question right? Hold on a second. feel like I didn't write down the question right. Let me make sure I write down the question correctly. Oh, this one's plus. There's a plus 3. Okay. So that's a plus. So that's how you get 0 over 0. Sorry, I apologize. I didn't double check my number. So that's going to be x plus 3 times x minus 2 over x plus 3. And this will cancel out. And then you can say limits as x approaching -3 of x minus 2. Now we can plug in. So -3 minus 2 is equal to -5.
I have a question. Why can't you just do the Hopper rule? Yeah, I know the limits, but like, why can't you just do that?
Very good question. You can do El Hapto rule. El Hapto rule can take care 90% of the issue. But there are 10% of the issue El Hapto rule does not take care. For example, absolute value. For example, radical. Think about if you have radical of x plus 1, right? The more you take a derivative, the more radical it goes to, because it's just going to go 1/2 power to the -1/2, and maybe you take one more, it's going to be more radical as it goes out. So not everything is always El Hapto rule. I will say El Hapto rule is a good option for 70-80% of the time. Now there are horrible options for like conjugate, for like certain things that they are really bad option. So some situation like trig limits sometimes can be awful as well. It's much better to understand everything. El Hapto rule used for harder problem usually. For example, let's say if I have El Hapto rule of, let's say, limits x approach infinity at x to the 100 minus x to the 99 over x to the 101 minus x to the 100, right? So do you want to do El Hapto rule here? Right? If you do El Hapto rule, that means you have to take a derivative top and bottom, because it's still going to be infinity over infinity. That means you have to take derivative 100 times to figure out this is going to 0. But you can factor out x to the 99, that's x minus 1, over x to the 100 over x minus 1. And that can be simplified, and that's equal to 1 over x. If you go to infinity, that's going to go to 0. Right? So it's not always El Hapto rule is the best choice. There are situations. So for example, Khrushchev and Raphael and Jin, you guys never learn about El Hapto rule. We haven't get there yet. So right now, just work on factoring cancel, which is in this case, factoring cancel it work. Okay. If it doesn't work, use El Hapto rule, because I would use that as a second option. But Wesley posed a good question. I also posed a good counter argument. So not just owning like the best thing to do some problem. So now I'm going to ask you to do a problem. So what happened when limits x approach to, I don't know, 2 of x cubed minus 8 over x minus 2? What happens if you plug in 2?
0, 0.
Okay. Do you see any cancel factoring? What'd you get? Ah, all of a sudden you guys forgot how to factor the cube, huh?
A squared may be in an E squared, so X squared. Squared minus 5.
Okay, so a plus minus b to the q is a plus minus b to the 2 equation. Same. Opposites. So that's how you apply it. So when I plug in 0 over 0, I say, okay, that means I have to do math. So limit x approach to 2, that's going to be x minus 2 times x squared plus 2x plus 4, right? Over x minus 2. This cancel. That's going to be 2 square root 2, 12, right? I think it's 12. Okay. So this is the first situation that we dealt with. The factoring cancel. So it could be any type of factoring. Sometimes it could be long division. You never know. So if you have a polynomial over a binomial, sometimes it can be a long division in order to cancel. So it's kind of like you have to know your basic math skills. Combined fractions. Let me give you one that's combined fraction, and maybe you guys can try to do that one because you already remember how to do that. And if you know your math, you should be fine. 1 over x plus 3 minus 1 over 3 over x. X approaching 0, yes. I think. Yeah. Do I need to show you how to do it? Or you got this? I'm just asking a simple algebra question. I don't think so. Huh? I don't think so. Anybody got a different answer? I don't think so. Who's got negative 1 over 9?
Okay, wait. So what am
I think Vincent's right.
He didn't like set it up. He expanded it. He didn't like.
So you see the main problem is the denominator x. The x is gonna go 0. That's why it's called undefined. Okay, so therefore it's gonna be limit x approach 0 at 3 minus x minus 3. So it's gonna be negative x, right? And this is a 3x plus 9 and times 1 over x. And x cancel out. So be limit x approach 0 of negative 1 over 3x plus 9. So that's equal to negative 1 over 9. Jin, does that make sense? You got it? Okay. Next one. The next situation that you might have is the first situation. We knew the answer was. So we knew the answer for this one is. So we're gonna show you that there was a question here. What happened when limit x over root x plus 1 minus 1? We did this last year as well. When it's a radical, what do you do? Conjugate. Do you guys remember what conjugate is? What is conjugate? Does that make sense? The whole idea is the bottom is causing you issue. But if I rationalize this, that will be x times square root of x plus 1 all over. That's the difference of squares, so it'll be x plus 1 minus 1. Does that make sense? It's the difference of a square. And that 1 cancel out. And the x cancel out. And then that's going to be 2. The answer is 2. We did it graphically, we find out it's 2 earlier. We did it algebraically, we find out it's 2. Good? And multiply by conjugate.
Oh yeah.
Can I move on or no?
I can see what you're saying.
All right, I'm gonna keep on going. Okay, we're gonna deal with one with absolute value. What happens if you have f of x is equal to x squared minus 4 all over absolute value x minus 2? And we say A, I want you to do limits as x approach to 2 from the left of f of x. B, when limits x approach to 2 from the right. C, I want you to find out what's the limit x approach to 2. Now, for those of you guys doing competition stuff, I need you, Sophia, Rajesh, and Nathan, make sure you know how to do this question. F of x equal to x squared minus 4, absolute value x minus 2. How do you limit x approach to 2 from the left, f of x, and limit x approach to 2 from the right, f of x, and also limit x approach to 2 of f of x? Don't just plug in numbers. I want you to actually establish how you find the answers. And this is something that I talk about, definition of absolute value. That's very important. And this one could be on competition question as well. This, Nathan, and this type of question could be on a competition question, but it's a little bit harder than this. This is relatively easier for competition, multiple choice questions.
Also, you can remember you can put into even though we can take out the main round, but we can't have to.
So remember I told you when you got the absolute value, right? When you have absolute value, that you are going to be using definition of absolute value. It will be make your life easier. So what does that mean? That means in terms of this, that x minus 2, that's 2 here, there's a function of x minus 2 here, and there's a function here of negative x minus 2. Since if I reach 2 from the left, I'm gonna be approaching 2 from the left of x plus 2 and x minus 2, and that's gonna be negative version of this. Does that make sense? Using negative version of this, and you can cancel that is equal to negative 4. So the answer is negative 4 for the first part. Don't just plug in number. On the test, if you plug in number, I'm not going to take it. I'm not actually, you show me mathematical way to get it, which is you had to use the negative side of the absolute value. In terms of positive side, then I can use the positive side. So it'll be x plus 2, x minus 2 over x minus 2. So now this x minus 2 cancel, that's equal to 4. Therefore, limit x approach 2, since they equal to 2 different value, that means does not exist. Does that make sense? Now, let's look at things graphically. Like, do you know what a graph looks like? Like what? It's gonna be, what was it, x squared minus 4, right? And the parenthesis divided by what? Absolute value of x minus 2. And it's gonna look like this. Two slanted line, they're on two separate sides, they reach two different values, and one's reach positive 2, one's reach negative 2. Because if you graph that one function on one side, if you graph the other function on the other side, it's gonna be a piecewise function. I break at 2. So limit x approach 2 does not exist. Raphael, push, Jing, good. I like Jin. Jin just give me thumbs up every time. Okay. I can move on. Alright, cool. So are we okay here? Now the worst thing last year was the trig limit. Do you guys remember that worksheet? Alright. So we're gonna talk about this. We're gonna talk about trig limits as well. What are 2 trig limits I asked you to memorize?
Oh, this comes to me.
That's the first trig limit. Second, limit x approach 0 of 1 minus cosine of x over x is equal to 0.
Should now be back from A1.
Trig limits. And you say, oh my god, trig limits, right? It's not that hard. It's just you gotta make math happen.
Make math.
Yeah.
Make math happen.
Make math happen.
That's what it means. Yeah.
All right. So, oh, I'm sorry. This is equal to 1. Sorry, that's equal to 1. My bad.
Oh my.
I'm so sorry. I gotta find a question for you though. Sorry about it. That's equal to 1. Make sure it's equal to 1. Now, the proof of that, you can use the El Hopital rule to prove that's true. Because it would be cosine of x over 1, and limit to 0 is going to be 1. Now, I also can be proving by squeeze theorem, but we're going to talk about squeeze theorem tomorrow, because Kevin, stop whining. My goodness. All right, so the next one. So we're going to say what happened when limit x approach 0 of sine to the 5x squared over x squared 2x squared, like this. I just named this question. I have no idea what I'm doing. Okay. The answer is not 2. So, remember, we try to make math happen. What is math in here? Well, this is sine of x over x is equal to 1, right? So we try to make that true. But the problem is sine of 5x here, and it's over 2x. So we can kind of adjust this. X approach 0. Can I write down sine of 5x times sine of 5x? And can I say that's over x and over x? Is that okay? And 1/2 is in the front because this 1/2 can be outside. Because we say limit of the constant, you can move outside. Are we good?
Yes.
Good?
Oh.
Okay. So what do I make this to make this true? This need to be what?
5.
5. This is also need to be 5. But however, I cannot just multiply by 1 over 25. I can multiply by 25 over 25. Because 25 over 25 is 1. I'm not changing the thing. I'm changing just the way it looks. So I can say that's 1/2 limit x approach 0. And I'm going to take a 25 outside in the front. So it's 25 outside in the front. Is that okay? And the 25 on the bottom is going to go inside. So it'll be sine of 5x over 5x. Times sine of 5x over 5x. Which is, that's equal to 25 over 2.
Oh, I have 2 lines times
I'm
25.
lost the stream.
The 25 confused me because I
was like,
Yeah, I was confused about the 25.
The 20, it's because you have to split the 25 into 5 times 5 because it's technically supposed to be sine squared.
oh, okay.
It's a little weird.
Oh, and then
Okay.
oh,
Oh, okay.
Congratulations, you guys passed third grade. 5 times 5.
your third graders doing college.
10 games in the same.
Oh yeah, long. That's long doing.
He's in college. No, he's at UCF taking Calc 2. He's 4th grade. He's 5th grade.
Also, the answer. Oh yeah, I want to meet him too.
Yeah,
I want to get a picture of him. If he gets famous, I should say I was
I don't even understand half the thing he says sometimes. That's pretty bad.
long. Wait, so
Okay, Jing, you understand? Okay. I like Jing. He just give me thumbs up all the time. He's like, oh, I got it. Huh? Maybe after he get this, we'll put him in math competition for sure. He's quick. I'm gonna have to test him a little bit though. You had to pass the next test. This is too easy for you? I like him. He's like, yeah, it's easy. Piece of cake. All right. So trick limits. You are gonna get a worksheet, trick limits. All right, airdrop to you. On top of this, you have other questions.
What?
making up for
It's your birthday? I'm gonna give you more homework. Happy birthday, homework. Jing, do you have airdrop or no? Huh? You do not? Okay, I'll
Airdrop to malicious
okay, I need you.
Someone get this put in the chat. Put it in the chat.
Please.
Yes.
Oh, just a you declined it.
Yeah, no wonder. Oh my god.
6 minutes. Oh, yeah. I don't know. Maybe you can press this file or something. Maybe the trigger limit file will be really big. I don't know. Yeah, it's I still have Eight minutes now. 5 minutes. Even over 5 minutes. 5 minutes.
5 minutes too
4
long.
minutes. Wait.
Oh yeah.
No, I think.
In the chat. Slow.
Like, why is it like here?
I don't know, but like there was no schoolwork and it was I'm blaming it on the time.
Appreciate it. Landon, you're like 8 minutes long. 4 minutes too long. Okay, well now it's not loading.
How much time I have? How much time I have? Huh?
We're giving
All right, you think I'm done? I'm not done. I'm keep on going. You guys have too much fun time.
What time we be at home?
Not math. Okay, I want to talk about one more thing. There is few different type of discontinuity, right? First of all, let's talk about definition of continuous. What is definition continuous? Do you guys remember?
Differential. Right?
No,
Oh, that was the other way around.
What?
That's the other way around.
no.
Does it
has to exist.
like after A after B after C, you know?
Ethan?
Is it change to A plus equal at limit f of x?
I think that's too complicated. Let's give me one thing at a time. There's 3 requirements for them to be continuous. Which 3? Yes. FAs exist. Good job. So that means I have I have a solid dot right here, right?
Oh, I remember.
What is the second one?
F of x, when x approaches A from the left equals f of x, limit f of x from the right.
Okay, so that's called limit. So limits
Yeah.
x approach to A of fx exists as well. So exists. So that means I can possibly have this, but it doesn't mean it's continuous. So this situation still exists, but it needs one last condition. What is the last condition? 2 and 1 equal to each other. Good, thank you. So the third one is limits x approach to A of f of x is equal to f of A. So technically, this here, that's gonna move here and just says, oh, now it's continuous. So there are 3 requirements. FA, or actually FA is not exist. FA must be defined actually. That's a keyword, define. Or same thing. FA must define limit x approach to A of f of x must exist.
What's the difference between those two?
Define just because there's a value. So I think defines a better word than exist. But they all probably means the same thing. Okay, so f of A is defined. Limit x approach to A of f of x exists. And limit x approach to A, that means it's left and right had to equal each other. So this means what? This means limits x approach to A from the left of f of x equal to limits x approach to A from the right of f of x. So this means that, but that doesn't mean it's continuous, because you can have the whole on top enriched there, but it's still not continuous. Do you remember this?
Yes.
Coming back? Okay, how many different type of continuous discontinuity there is? Can you remember? There are 2 type of discontinuity. Do you know which one is it? Whoa, holy horse. How many type of discontinuity are there? Raise your hand if you know. Yes, Ria? Two. Which two?
Non-removable and removable.
Okay, so what give you removable discontinuity?
Yeah, it's the open hole.
It's a hole. Okay, so let's look at this case. Let's look at f of x is equal to I don't know, x minus 2 over x squared minus 4, like this, right? So where's the removable discontinuity? If you factor and cancel like normally you would have done, the things that you cancel here, right? You cancel this is, don't forget to put a 1. Last year a lot of people don't put a 1 on the top. So the thing is you cancel is going to give you a hole. Hole is also known as a removable discontinuity. So there are two types. Okay, removable discontinuity. So where's the hole? Hole is when you set the cancel factor. Equal to 0. When you set the cancel factor equal to 0, x minus 2 equal to 0, x equal to 2. Now you plug into the new equation. So 1 over 2 plus 2. So equal to 1 over 4. The whole location is going to be at 2 comma 1 over 4. So this is known as removable discontinuity. Why is it removable? Because it's a hole. You can just plug in the value, it's going to fill in the hole. Removable discontinuity. Got it? Am I going too fast? No? Now, where's non-removable discontinuity?
Jump.
Or it can be jump. What else? What? Guys, what? Unbounded graph. Okay, that's good. Asymptote, vertical asymptote. So a non-removable discontinuity. Non-removable discontinuity is a vertical asymptote. A jump, like the one with absolute value, the one we just did is a jump. That's called jump discontinuity. It's also called non-removable discontinuity because you cannot remove by just plugging a single point. That's called jump. So there are two types of non-removable discontinuity. How do I ever find a vertical asymptote? Set denominator equal to 0. So set denominator equal to 0. Equal to 0. So denominator equal to 0 is going to be 1 over x plus 2 in this case because that's a new function. So vertical asymptote is happen at x equal to -2. That is going to be a non-removable discontinuity. So last year I also asked you non-removable discontinuity, removable discontinuity. Got it? Good? How much time I have?
3 minutes.
Okay, then I'm not going to teach you anymore. I'm going to stop here. You guys got homework. Oh, darn. Oh.
Yeah, that's.
Yeah, I'll pack it and a few more questions.
Oh, thank you, Mr.
You might need to use your trick identity though.